that the minimum temperatures are coming up, the average temperatures are coming up, and I'll tell you in a minute how the maximum temperatures are changing too. So with this comes earlier snow melt, which is a big deal for forest health and for fires, as you can probably imagine. I'll get into that a little bit more. Earlier leaf out on our trees and plants. And then we're seeing longer growing seasons, which also can make our plant species more susceptible to the cold because there's a shifting season piece, which I'll talk about. We have greater rainfall intensity and generally increased precipitation, which is for the fire folks in the room. Okay, yep, we knew that. What does that mean for fire? And also possibly more drought. And I'll talk about how that's possible. And sea levels, even though it's not relevant to this presentation, is rising faster in the mid-Atlantic than I believe certainly anywhere in our country. Okay, so these colors look funky here, but this is that maximum daily temperature that I mentioned. So we are, I don't want to miss anything important here, so I took some notes. We often talk about average and not maximum in our part of the world. But in April and November, the red is showing more change. This is 3 different emission scenarios and timescales. But orange and yellow, in this case it's like green and lighter green. They're still showing change. All of this is positive change that we're seeing, which is that basically the last spring frost and the first fall frost are moving further apart, and that maximum daily temperatures have increased in April in like the Maryland, Delaware, New Jersey area, and in November in Vermont, New Hampshire, Maine, New York. So hotter in the spring and the fall months, which longer growing season. Oh, there we go. Okay. More precipitation. This is a map showing the increase in size. The darker and the bigger dots are the more increase in intensity of storms. So this is the number of storms that drop more than 2 inches of rain in 24 hours. That is happening, as you can see, we know it because we're in this part of the world, but that's happening more here than anywhere else. Okay, here is what the projected change is in seasonal precipitation. So I talked a little bit about the growing season getting longer and what's happening in precipitation, but here this is winter is up in the left side, and then we go spring, summer, fall. So really we're not seeing as much change in the summer, fall, which still precip but not as much. But boy, we're getting wet springs, and more so in the north. And then thinking about what happens in the summer and fall is when we start thinking about when the droughts are occurring. So not only are we getting these more precipitation, they're all coming at once in these giant downpours. And that's because with warmer air, there's a greater capacity for the air to hold water. We also have increased evaporation. And then we have a vapor pressure deficit, which I'm going to talk about, where moisture is being pulled from the soil and the plants. And all of this causes more extreme precipitation events. Oh, and one more thing, lesser winds. So our storms are slower. So they're dropping more in each event because they're moving more slowly through. Heavier, more frequent, and the greatest increase is happening in the Northeast. Why am I talking about rain so much? I'm talking about fire. Amanda told me not to talk about rain. Okay. But what does this all mean? The storms are coming. There's more precip. That's a very clear trend. It's already happening. It's been happening. It's projected to happen more. well, what about this drought? Aren't we seeing more drought? How is that possible? Well, if the storms are if the storms are getting bigger and more intense and more rain is dropping in those intense storms, what's happening between those intense storms? And sometimes the answer is drought. The higher temperatures lead to increased rates of evaporation, and that also includes the more loss of moisture from the plant leaves, and we get these things called flash droughts where there's an increase in the saturation of the vapor pressure and an increase in evapotranspiration. So drought is increasing, and it's documented in parts of the globe as part of climate change. It is not clearly attributed to climate change in the Northeast yet. But we are seeing it and watching it, and there are possibilities that it's connected. And here is one study that looked at the future change in ABDI, and it shows, so this is again winter, spring, summer, fall, and again the red or the darker colors are the greater, the drier conditions basically, the greater change and increase in the drought, for the drought index. And so you're seeing it more in that, in this case it's in the east, it's summer and fall, but increasing across all months. Okay, I mentioned vapor pressure deficit. This might be the coolest thing I'm going to talk about in this talk. Okay, so air temperature, are you guys all pretty familiar with vapor pressure deficit? I don't need to describe it. Okay. Air temperatures are going up, and with that, the vapor pressure deficit increases. So the deficit is the difference between the amount of moisture in the air and the amount of moisture in the air that is at saturation, and saturation is 100% relative humidity, okay? So when the deficit goes up, there's a drying effect on the plants and the soil. Moisture from the plants is transpiring and evaporating from the soil into the air to fill that deficit. Warmer air maintains more water as vapor, which is kind of the right side of that leaf diagram, and that puts more demand for moisture on the plants. So as it becomes warmer, as the temperatures go up with climate change, there's more water vapor, which is creating those storms, but it's also equaling more deficit, as I just described, which puts more pressure on the plants in the soil for the moisture that they have in them to end up in some drought-like conditions. The maps on the right show the percent change in vapor pressure deficit based on projected climate change, and that's all lower and higher emission scenarios. So that's off the charts for the red there. Very, very high increase. Pretty cool, right? Pretty interesting. Okay, this is one of my favorite things about climate change is that there is, I shouldn't say favorite, we don't know what the effects are. I'm pretty interested in it. There's this concept of global stilling, which is that there has been a global decline in winds in the last half century. As the climate warms, the differences in temperature between the equator and the poles is less because it's warming more at the poles. So it's becoming more closer, more equal. So wind is really just the movement of air from low to high pressure, or high to low pressure. And so if the temperature and the pressure is more even around the world, there's less reason for the wind to blow. What does that mean for pests and fire? There has not been a lot of research on global stilling, but it's pretty fascinating. Okay, my other mention of climate change that we don't always hear about, or maybe you do on the Weather Channel, these wacky jet streams. So we call them wacky because jet streams are fast-flowing, narrow, meandering air currents in the atmosphere. In the northern hemisphere, they go from west to east, and the jet streams are basically becoming caked, and so that they're looking more like that picture on the right, and carrying cold air south and warm air north. Why that's happening, there are many thoughts on that, and Erin has an answer answer all your questions on. That is another, no pressure. There's another whole talk. But that is affecting our weather, but it is a product of climate change. Two resources, I mean, I just gave you guys a quick overview. Two resources that I suggest is the NOAA State Summaries. It's a 4-page summary on trends and projections for what's happening in your state. Super specific to your state. So you don't have to look at that 1.8 degree Fahrenheit per decade, whatever it might be. It is for your state, this is how much the climate has changed and how it is projected to for temperature and precip. So I suggest getting that one. And then the other one is the 4th National Climate Assessment. There's a chapter specific to the Northeast, and there is a chapter specific to forests and ecosystems as well. Hundreds of authors spent a tremendous amount of time, scientists, writing this document. It is very informative. All right, now we're getting to the impacts on forests, which you guys probably have already, I mean, once you know what the climate, how the climate is changing, you guys know the forests, and you know what the effects will be. But I'm gonna call them out to some extent. So we can sometimes see, mortality due to the drought in trees, and also mortality due to flooding. Thirdly, the sea level rise is causing a salinization of some areas, and depending on how salt tolerant the species are, that is changing ecosystems. That's like the ghost forests that are happening with the Atlantic white cedar in New Jersey and other places. Something that we focus on more is the shifting seasonality. We talked about the longer growing seasons, that earlier snowmelt and earlier spring, where it feels like spring, and so the trees are budding, and then it gets cold again because it's normally cold in those months, and that makes them more susceptible to a whole host of whatever might come next: insect disease, fire, etc. Because it's weakening the trees. So there's these altered ecosystems, altered plant-animal interactions because the synchronicity is mismatched, and also there's impacts to plant productivity. And as we're talking about, this has implications for pest and wildfire as well. And in general, we're seeing increase, although there's plenty of examples where it's decreasing as well, depending on the forest type. So forest composition is changing. There's one more resource to write down for you. This is the Tree Atlas. You just type in Tree Atlas. This shows what the overall forest composition, how the overall forest composition is changing. So it's potential changes, and it shows potential changes under different climate scenarios. This one I did for red maple, and you can see it increasing in the potential emission scenarios. That was just an example, though. So you've heard a lot about pests and forest health in this meeting. There's a lot of experts here, and many times you've heard, I've heard anyway, this reference to climate change. And climate change is expected to increase the effects of some insect species in our forests, but also reduce the effects of others. We tend not to notice the reduced effects quite as much. We put our focus more on the increased effects, but both are happening. So for example, the drought increases the populations of some defoliating insect species, but it also decreases populations of others. Warmer winters are likely to contribute to the earlier insect emergence, which has effects on how many life cycles certain insects can have in one season. And then there's also this idea of expansion of geographic range and the population size of the pests. Oh, and weakened trees may be more susceptible to either pest damage or diseases, like the leaf diseases in eastern white pine. So southern pine beetle is an example outbreaks of southern pine beetle. However, there is quite a bit of evidence that it has impacted its range, which I know you've already discussed today, but here's a map showing the projected migration of the southern pine beetle, which maybe it's already in some of those places, huh? Okay, so insects interact with fire as well, which compound the effects on the ecosystems. The intensity of a fire may be greater in areas that were impacted by an outbreak. I think we'll hear more about that in the coming talk. The mountain pine beetle is a great example of this happening. Dying trees can be more susceptible to mortality after a fire. So even if they're not more susceptible to the fire itself, it may be more likely to die. And it all depends on a lot of variables in topography and fuels and fire weather, how it actually impacts either the fire or the possibility of a future pest outbreak. A few studies have been done in California on this idea of do insects actually create more fire, and so with the drought in the western pine beetle, they have showed that the dying trees from the beetle have made the fuels more available for fires, which makes sense, and that research is happening and it's likely a possibility in the Northeast as well. I wanted to also mention, oh no, whoops, we're not there yet. So climate change impact on fire. I mean, we saw the rain, we saw the drought. You could probably guess how that all affects it. There have been some studies on the relationship in the West between the aridity of fuels and burned area. So they have shown, that's that study on the right there, that in these areas, the fuels are becoming drier due to climate change, and that is increasing the amount of area that's being affected by fire, the larger fires. We also have these longer fire seasons. Very large wildfires in some areas have been happening and are projected to. There is thought that there will be less in other areas. But overall, fuel loads in the fire regimes are changing. Sorry. Climate modeling actually indicates that lightning activity will increase by 12% per degree Celsius of warming in the U.S. So that's a 50% increase over a century. Have people heard that before? It's pretty interesting. That came out in NCA 4. Okay, I mentioned earlier snowmelt. I don't want to talk about that too much more, but there is the warmer spring and summer temperatures that are leading to the earlier snowmelt, and also in some cases lower summer and soil and fuel moisture, and that's contributing to the longer fire season. And we talked about that forest health piece as well, because it leaves trees that green up earlier susceptible to the cold. How does drought affect fire? We have quite a bit of information on that, where if you're increasing the number of days in the year with flammable fuels, it extends the fire season length, not just the growing season length. And the area burned in certain ecosystems is directly related to the fire extent. Overall, I mean, what it comes down to is it's different for every ecosystem, and our fire regimes, our ecosystems, the forest composition is slowly changing over time and projected to change over time. So if climate is the limiting factor for fire, which it sometimes is in some areas, rather than the fuel, then the potential for the larger areas to burn as fire regimes shift across the ecosystem exists. So there's complex, in the Northeast especially, there's these complex patterns of land use and active prescribed burn programs that make the prediction of future wildfire particularly difficult. However, they have done a really good job of it in other areas of the U.S. where they do have a better sense of how fire is changing with climate. And here's some examples in mostly the west here and also the southeast. And to the right of the colon is the driving factor, the factor that's driving that change. As I'm wrapping up here, I wanted to mention something that we hear a lot, especially prescribed burn. I put this slide together for prescribed burn boss training because prescribed burn boss get a lot of comments from the public about climate change, and one of them is, well, you're causing climate change by releasing carbon and putting CO2 into the air, and that is true. There is some truth to that. There is definitely a feedback loop there where if the climate is causing more fires, then the fire is actually causing the climate to change further. However, be assured that wildfires are not the leading cause of global warming. It's burning fossil fuels, but they do emit some gases. It's hard to find exactly what percentage it is of CO2 in the atmosphere that can be attributed to wildfires, and it varies drastically depending on the year, how much fire there actually is, and it also varies depending on the fuel type and the ecosystem type. And relevant to that, and a little shout out to the Prescribed Burn Councils and the new focus of the Fire Science Working Group to think about prescribed fire. Fire interacts heavily with the carbon cycle, which there's a whole other talk there, but prescribed fires are often set to decrease wildfire, so how does that fit into the feedback loop? It may actually be slowing that emissions, because the prescribed fires tend to, these are real pictures of, well, that's actually a prescribed fire on the left too. They're both prescribed fires, but it's showing they were measuring the emissions and how much greater it can be in a crossfire. So just to summarize, we talked about warmer temperatures, the increased rain, but also the possibility of increased drought. That really cool topic of vapor pressure deficit. Definitely seeing the pest pressures increasing and then how it all interacts and compounds for a unique future that we have with climate change. You guys have any questions? We have a few minutes for questions, I think.
Hey, Erin, I have a comment, just an illustration, I guess. Two of our most notorious insect pests in Maine come to mind with Erin's presentation, one being spruce mudworm and the other being brown-tailed moth. And they are kind of opposite in how we expect them to act with those increased temperatures in November. With pressures potentially becoming less with spruce mudworm and potentially becoming more with brown-tailed moth, just based on their life cycle. So it's a good sort of local illustration of how the sky might impact forest health and human health in particular.
Awesome. That is a great example. Yeah. Thank you, Allison. Now, Eric will be much more